Hey everybody, this is Mr. Storm, and in this week, this very awesome week, we're going to get started on the last project we're going to build for this class. For the next 4 weeks, we're going to be working on the Spirits of the Forest project. This is a traditional 2D side-scroller, 16-bit Super Nintendo style game, and we are going to be building that game together. Step by step. This week we're going to be mainly focused on building our character's movement. We've done character movement scripts before, but this one's going to be a bit more advanced than anything we've done in the past. It's going to incorporate physics. It's going to incorporate all of the stuff that we've learned so far. And we're going to learn a couple of new things too that we haven't even talked about yet. So it's going to be a good week. We're going to learn a lot. Now this game, the idea of this game is essentially, it spawned from a conversation I had with my daughter once. She was kind of complaining that there aren't too many games with little blonde girls as the main character. And I said, you know what, you're actually right, so let's make one. So we actually sat down together and kind of came up with the idea for the game. And the game is, this girl is lost in the forest, and there are these spirits that are represented by these orbs here. And she has to collect all the spirits to save them from the evil forest, right? She's got to get from one end of the level to the next while collecting all of the spirits that she can find. When she gets here, then a screen will pop up saying you've collected all the spirits or you've saved all the spirits, something to that effect, only if she's collected all the spirits. All right, so it's a very simple game, but we're getting a lot done. We're doing a lot in just building this game. So you're going to learn a ton of programming concepts here. Okay, so let's go ahead and get started. I want to start doing something with this main character. I want this main character to do something. Let's see what the game looks like when we first play it, however, so we can see what it looks like without any scripts. Okay, so you may not be able to hear that, but there's some background music playing. That's because the main camera has, as a child of the main camera, there's an object called sound effects, and then inside we have a music object, which is an audio source, which is set to play on awake and loop. That's our background music for the level. Then we have a collect sound effect, which we're going to have to write a script to handle whenever we collect a coin or a spirit. It's going to play the sound effect. So that we'll do later. We also have this background here, which isn't fitting into our camera. That's because the background, at some point, we're going to make that background parallax. Parallax means there are layers to the background, and the layer that's closest to you will move at a different speed from the layer that's farthest away from you. That way it kind of looks like there's some depth, some 3D depth. All right, so that's going to happen. We're also going to make sure that we can collect these orbs. We're going to, when we approach these spikes, we're going to have the spikes kind of shoot up at us. Okay, so there'll be some movement when we get close to the spikes. Yeah, we'll update our user interface as we're going through the game. There's a lot to do. Okay, let's get our character moving here. I'm going to go to my scripts folder, which is empty, and I'm going to create a new C# script. I will call it player. And then I'm going to attach my player script to my player object right away, so I don't forget to do it later. And let's open her up. Beautiful, 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 beautiful. Okay, so let's get rid of the comments, as I kind of don't need them. Let's talk about what we actually want to implement in this game. Well, first, we need a move, right? So if we're moving, we probably need a move speed. So let's make this a public variable. Public. We'll make it a float. Move speed. We'll set that equal to, let's say, 10. Then, now we want to set a slider for how much we actually slide when we let up off of the movement button. So here's the thing. When you're pushing a button in Unity and then you let go of that button, the script will execute as soon as you let go of that button. But if we have that in a movement, it kind of just stops immediately and it's abrupt and it doesn't feel natural. So what we can do is we can create a public slider, which will allow us to set the range for when for how much we move after we let go of the button. So let's do that. This range object here, or this range thing that we're going to create, will allow us to create a slider in the Unity inspector that will let us choose between a range of numbers. For us, it's going to be 0 to 1. Public float sliding, and we'll set it equal to 0.9 for now. Yeah, that looks good. We also want a jump force. We want to see how, we want to set a number for how much force we're going to give our character whenever we hit the jump button. So we'll make this public as well. Public float jump force. And we'll set that equal to 1200. And then we need a couple of references to some objects we're going to call often. We're going to call the rigid body 2D of our character often in the script, and we're going to call the animator component in this object, or in this script often. So we'll get references to both of those. So I need a private, let's say rigid body 2D, and we'll set that to player, and we'll get a private animator. Let's call this player anim. All right, beautiful. Okay, so that is done. Now in our start method, we want to grab references to those. Player equals get component rigid body 2D, and then player anim equals get component animator. Okay, so now we're ready to actually start writing the script and making this stuff happen. All right, first thing we need is we need to figure out our horizontal, we need to get our input from the horizontal axis. We'll store this in a float called h, and we'll set it equal to input dot get axis raw, and we'll tie it to the horizontal axis. Then we want to set a vector 2 for our v, for our vertical, because have we talked about this yet? I think we have. Vector 2 equals player dot velocity. Okay, so basically what we're doing here, because we're basing our movement on physics, we're not going to worry too much about our up and down movement when it comes to going left and right, because the only thing that this input needs to handle is going left and right. Our up and down is going to be handled by our jump. But when we add force, we also can apply movement to the force as we add it. And we want to be able to move our character kind of back and forth in the air. You know, pretty much every 2D side-scrolling game that you play that allows you to jump allows you to change your direction and move your character in the air. So like if you jump and you're like, uh-oh, I miscalculated, it lets you come back. Totally violates the rules of physics, but it feels weird if you don't have it. So we're going to make sure that we have that option here. Okay, so let's set up our basic movement. If h does not equal 0, meaning if h is -1, if h is +1, then that means we're moving somewhere. So we need to do a couple things. First, let's update the animator. Player.anim will set bool is running, and we will set it to true. So here's what we're doing with this. All we're doing is we're getting access to the animator component on our main character. So let's take a look at our main character. So our main character has this component here called the animator, and that animator is controlled by an animator controller. So if we go into the animator controller, we can see that we have an animation system all set up here. We have 3 animations. We have idle, jump, and run. Now, if we're running, we want to go from idle to run. Now that transition is based off of this condition, if is running is true. So in our script, when we set is running to true, that will transition from the idle animation to the run animation. You with me so far? Okay. All right, so we're changing our animation, and then we want to change our velocity. So player dot velocity. And we're going to set our velocity equal to a new vector2, oh, hello, h times move speed. Okay, so that's setting our horizontal movement. And then the y, basically, you know, our up and down is just going to be v dot y. And what that means is we're basically just going to keep the same velocity and keep the same y value. Okay, then else. So if our h is 0, meaning we're not moving, then we want player anim set bool. We'll copy and paste. Is running to be false, right? Because we want to go back to idle. And we want to set our velocity to set up that slide. We want to start sliding. So it'll be a new vector2, and it'll be v dot x times sliding. All right. So what that's going to do is that's going to allow us to slide just a tad after we stop moving. Okay, well, we can test this, but actually let's do one more thing before we test this out. The way this is set up now, if I was to run back and forth, my character would always be facing to the right. Even if we were running backwards, she would be kind of like moonwalking in the scene. We don't want that. What we want to do is we want to flip the X on the sprite renderer whenever she's moving to the left. So that's very easy to do. Let's set up a simple if statement. If h is less than 0, meaning she's moving to the left, then we'll get component sprite renderer. You know, I probably should have created a reference for this, but that's okay. Flip x equals true. Else, and we'll just copy and paste this. Copy, paste, we'll set it to false. Okay, at this point I should be able to move around in my game. Let's go ahead and save. We'll go back to the game, and where's my player? We'll go to the scene. Okay. Perfect. So you can see here that I have my move speed and I have my slider where I can set the amount of slide that I have. I don't know about you guys, but I think it's pretty cool that Unity allows us to create public variables and not just to enter text, but also to, you know, slide some, create a slider or add a, you know, a game object selector area. Like, that's so cool to me. All right, let's go ahead and play it out and see if it works. So I'm running back and forth. Perfect, perfect, perfect. And I can't jump yet, but it looks like my animations are working and I'm able to run. That's good. That's what I want. Perfect. Okay, let's go back to my script. Now let's talk about jumping. In order to jump properly, we are going to need to create a special method. And this method is called isGrounded. All right, so we're going to go underneath my update method here. And we're going to create a new bool method called isGrounded. All right, now this is going to be a bit complicated to explain. I'll try my best, but I'm not sure if I'm going to be able to really articulate what we're doing here in a way that makes sense without getting into too much heavy math information. Okay, well, the first thing we need to do is we need to check the bounds of the object that this script is attached to. We need to check to see what are the edges of the object. All right, so we're going to create a new bounds object. We'll call it bounds. We'll set it equal to get component collider 2D. So basically we'll get the collider on this object dot bounds. So the bounds of the collider. So that's all we're doing. We're just figuring out what are the edges of the collider. Now what we want to do is we want to figure out the range. And this is going to be the height of the collider. It's going to basically be 10% of the collider, right? So the range of the height of the collider times 0.1. Okay, so let's do that. Float range equals bounds dot size dot y times 0.1 f. Okay, so this is basically just figuring out what's 10% of the height of my collider. Then we want to create a new vector 2. We'll call it v. We'll set it equal to a new vector 2. The first, or the x, is going to be bounds dot center dot x. So the middle on the x-axis, the middle of my bounds, right in the middle. The y is going to be bounds. My dog is whining out there. Bounds dot y, dot y minus range. So that range that we just created, which is 10% of the bounds, we're basically just figuring out the middle on the x, and then the basically 90% of the bounds here. Hold on, let me let my dog in. He's whining too much. Are you coming in, buddy? You just want to whine? Okay. He just wants me to feel bad for him. Okay, so now that we have those two numbers stored into a vector 2, now what we want to do is we want to emit a ray. We want to do a ray cast. All right, this is not ray tracing. All right, don't get excited. This is ray casting. What we're going to do is we're going to start at the center of our object, and we're going to cast a ray directly down. Basically, we're just going to send out a feeler directly down. And if we collide with anything, then we're going to be considered ourselves as grounded. We're going to be considered grounded. If we don't collide with anything, then we're not grounded, which means we're in the air. The reason why we want to check if we're grounded is we only want to be able to jump if we're standing on a solid object, right? So every time we hit the jump button, we're going to program this later, we want to cast a ray below us, and if we hit an object, we want to be able to jump. But if we're in the middle of the air and we hit the button, but there's nothing directly below us, then it won't do anything, right? So that's why we're doing an is grounded. Okay, so we're going to create a ray cast hit, and we'll do it 2D. We'll call it hit, and that'll be equal to physics, spelled physics wrong, physics 2D dot line cast. This is when we actually send out our line, and we're going to send it v bounds dot center. So if you look here, it says line cast has two arguments. The first is where we start, and the second is where we end. Okay. Then we will return hit dot collider dot game object not equal game object. That is basically determining if we hit something. If we did, it'll return true. If it didn't, it'll return false. So now we have this is grounded method. This is a pretty standard method. There's a little bit of glitchiness with it. It doesn't work perfectly, but so far for our purposes, this is good enough. Okay, so now that we have our is grounded method figured out, we want to come back up here to our update method, and we want to basically figure out if we're grounded. So let's do bool grounded equals is grounded. Okay, so that's just determining if we're grounded or not. Then we want to say if, let's do input dot get button down. Now you haven't seen get button down yet. What this does is it accesses an axis in Unity, just like we did with the horizontal and vertical. But the axis can be jump. And a get button down is basically just boom, you just hit it. It's a boom, it's a button, right? So get button down. For us, it's going to be space or joystick button 2, which I'm going to use a Super Nintendo controller to move around in this game, and so I want it to be set to a button so I can hit a button on my controller. Okay, so get button down, and we're going to call it jump. So whatever the jump button is. So if we push the jump button, and there we go, grounded, meaning we're on the ground. This is the whole reason we wrote the is grounded method. Then player anim dot set bool is jumping true. Basically, we want to change the animation to is jumping. Then player dot add force. It's going to be vector 2 dot up times jump force. Times jump force. Okay. Now, when we're not jumping, we just want to set our is jumping back to false. So let's go ahead and copy this, set that back to false. And let's save it. Oof, that's a lot. That's a lot of stuff that we just did. So we're going to save it again just to make sure. Let's come back in here and let's test it out. See if it works. Oh man, look. Oh, that feels good too. It works perfectly. And I'm trying to double jump, but it's not letting me double jump, which is good, which means our is grounded method is working perfectly. Now there's an issue here. We can go off the screen and the camera won't follow. We're going to fix that next week. That's kind of an issue. We can kind of stick to the wall, but honestly, with this game, it's not going to be too much of a big deal. Perfect. So if your character can jump around and move and all that stuff, then your game is basically ready for this week. You've successfully written a player movement script. Okay, perfect. So I will see you next week where we will continue working on this project. All right.